Hey, it's T. I'm one of the geniuses at Ask Zylor. So let's just get started with the live session.
So we'll jump to our next question, which is a grade 12 data management question. So it's dealing with probabilities with permutations. Okay. So this question's telling us 6 friends go to their favorite restaurant, which has 10 different dinners on the menu. If the friends are equally likely to pick any of the dinners, what is the probability that at least 2 of them will order the same one? So we ask, what is the probability at least 2 friends will order the same dish? So that is the same as saying, what is 1 minus the probability that no one picks the same dish, right? Okay, so how do we find this out? We get 10, choose 6, right? So this is going to give me the number of ways that one can select the number of different dishes. Sorry, ways. Dinners, right? This ends up being 10 times 9 times 8 times 7 times 6 until I get to 5, right? So this ends up being, if I plug it into the calculator, it ends up being around 0.1512, right? So that's the number of choices if they are able to select the same dinner, right? So if I subtract 1 from that, it's going to tell me, yeah, I have to divide by 10 to the power 6. Right. This is going to tell me the probability that no one picks the exact same order. Right. So 10 to the power 6 essentially is going to be 10 times 10 times. That goes on 6 times. Right. So if I say this is the first person, this ends up being the second person, and so on. Okay. So when I find that when I plug that into the calculator, I get 1 minus 0.1512, which ends up being 0.848. Right? So it's about 85% chance that at least 2 will select the same dinner. So just to recap what we did, we were asked to find the probability that at least 2 people will order the exact same order. So what we ended up doing was we did 1 minus the probability that no one picks the exact same dish. Right? So that ends up being 10 permutation of 6 divided by 10 to the power of 6. So that's going to give me the number of ways to select different dinners, divided by the number of choices if they're able to select the same dinner. So that ends up being about 0.15. So when I do 1 minus that, I end up with 84. It's 85, right around about 85% chance that at least 2 will select the exact same dinner. Okay, so we'll go on to the next question. So this is a grade 9 math linear equations question. So we're given an equation which is 1.13t is equal to 75n plus d. So they've given us some context behind this question, this equation. So the t represents the total cost of the car before tax, n represents the number of monthly payments, and d represents the amount of his down payment. So we asked, how many monthly payments will this person have to make if the car cost $2,000 before tax and a down payment was $535? So we're given the d and t values. We're told t is equal to 2,000 and my d is equal to 535. So what I had to do is sub these values into my equation to find the n value, right? Because the n value is representing the total number of monthly payments, and that's what the question is asking me for. So I'm going to do 1.13 times 2,000 is equal to 75n plus 535. Right. So when I multiply the 1.13n, I get 2260 is equal to 75n plus 535. Then I can take away 535 from both sides to give me 1725 is equal to 75n. Right? I did that by subtracting 535 from both sides. So then I'm going to isolate for my n by dividing both sides by 75. So this gives me 1725 over 75, which is 23 months. So n is 23, which means my answer is going to be, this person has to make 23 payments to cover the cost of $2,000. So if you're just joining in, if you have any questions that you want us to do, if you need any help, send us a message. We'll be happy to help you guys out. Okay, so all these questions are questions that students have been sending in, questions that we see throughout the week. All right, so we're going to move on to the next question. So this is dealing with exponents. So we're asked to evaluate the expression, leave the answer in rational form with positive exponents. So we have to simplify this expression and then plug in the values afterwards, right? Simplify the expression until we end up with positive exponents. So we have 81 x to the power 4, y to the power 6 times 1 over 2, and then 8x9, and then y3 to the power of 1 over 3. So let's go ahead and simplify this before we start plugging in the x and y values. Right? So we have to evaluate the brackets first in terms of bed mass. So we have 81 to the power of 1 over 2, and then x4 has an exponent of 4, so I'm going to multiply 4 by 1 over 2 to give me 2. And I'm going to do the same for y. So y has an exponent of 6. So I'm going to multiply 6 times 1 over 2, which is half of 6, which ends up being 3. All this is going to be divided by 8. And then I'm going to do a similar situation with the x and y's in the denominator. So 9 times 1 over 3 ends up being just 3. And then y to the power 3 times 1 over 3 ends up being just 1. Right? So exponents, when I have something raised to the exponent of 1 over 2, the 1 over 2 tells me that I'm going to find the square root of that term. So 81 to the power of 1 over 2 is essentially square root 81. Right? So I can get plus or minus 9 as my answer. Right? So let's say we're given 9, I'm going to say plus minus 9 for now. Right? And then I have x squared y cubed over 8 x cubed y. Right? So then I can simplify this further by evaluating what the x's and y's will simplify to. Right? If we divide the same term with different exponents, we subtract the exponents. So I have 9 over 8, so this is still plus minus 9. So I have x 2 minus 3, then y 3 minus 1. Right? And then this would simplify to still plus minus 9 over 8. X would be negative 1, so I want positive exponents, so I'm going to leave x in the denominator. And y would be 3 minus 1, which is 2. So that's what I end up with. Right? So the question is asking us to simplify and then evaluate. So we're given values for x and y. So x is 10, y is 5. So I need to substitute those values in. So x is 10, y is 5. So I'm going to do plus minus 9. My y value is 5, so it's 5 squared. Then 8 times my x value is 10. I'm going to plug that in. Right? So this ends up being plus minus 9 times 25. Right? Over 80. I can simplify this further by just dividing 5 from both these terms. And this ends up being plus minus 45 over 16. Right, so this is my final answer. Okay, so I'm going to jump to the next question, which is a grade 10 quadratics question. So it's asking us which equation is correct for the graph shown. So we're given a couple of equations. It seems like they're all in vertex form. Right? And it seems like looking at the vertex, they all have the same vertex, but the only differing factor is the a values. Right? So the vertex is -2 and -2, which is correct in every single equation. So we need to find the a value, right? So let's set up an equation and find that a value. So we have a x plus 2 squared minus 2. So let's go ahead and pick a point on this graph that we can substitute in so we can find the a value. So an easy point would be just 1, 1. Right? So if I substitute 1 and 1 into this equation, I end up with squared minus 2, and then I can isolate for my a value. Right? So I'm going to rewrite this down here. So a 1 plus 2 squared minus 2. So let's find out what that a value is. So I'm going to bring the 2 to the other side. I have 1 plus 2, and then a, the inside evaluates to 3 squared. So I have 3 is equal to a times 9. Then my a value would be 3 over 9, which would simplify to 1 over 3. So my equation should look like this: 1 over 3, x plus 2 squared minus 2, right? So come up with an equation and then try to match it with some of the options given to you. So my a value is 1 over 3. The only answer that accepts that as possible would be B. Right? So once again, if you have any questions, send us a message. We'll be happy to work through that. So let's go ahead to the next question. So this is a grade 12 calculus and vectors question. It's a vectors thinking question. So we'll do part A and part B for this. So for part A, we're asked to find all the unit vectors that are parallel to xy plane and perpendicular to the vector 1, -2, and 2. Right? So if any vector is parallel to the xy plane, that means there's no z component. Right? So we're going to say it's just a vector. We're going to give it some variables for the x and y, but we're going to say 0 for the z component, right? Because it is parallel to the xy plane. There's no z component. And it's telling us it's perpendicular to the vector 1, -2, 2. So we should know that two vectors that are perpendicular will give a dot product of 0. So let's try and use that to advantage and say, if I take the dot product of 1, -2, and 2 with this new vector that we found, a, b, 0, that dot product should be 0. So let's try and find what the a and b values are. Right? So if I do the dot product, I end up with a minus 2b is equal to 0. So I end up with a is equal to 2b. Okay? So if I let b is equal to 1, right, that means my a would be 2. If I just plug this into that equation. Right? So I have a vector. I found the a and b values now. So I have 2, 1, and 0. Right? It's perpendicular to the vector given to us, which was 1, -2, -2, and 2. It's perpendicular to that. And it's parallel to the xy plane. Right? It satisfies all that. But the question is asking me to find a unit vector. So this is not a unit vector. So how do we find the unit vector? We take this vector given to us. Right? So let's call it u right now. And we say that vector divided by the magnitude of that exact same vector will give us a unit vector. Right? So the vector is currently 2, 1, and 0. Divided by the magnitude would be square root of 2 squared plus 1 squared plus 0 squared, which ends up being square root of 5. So I have 2, 1, 0 divided by the square root of 5. Right? And this evaluates to 2 over root 5, 1 over root 5, and just 0. Right? So this is one of the unit vectors. The other unit vector could be the negative components of the xy. Right? So I can get -2 over square root 5, -1 over square root 5, and then still 0. Right? I got all this because I initially said b could be 1. If I used any other number, I should simplify to the exact same unit vectors that I found over here. Okay, so let's go to the part B of this question. So we're asked to prove a following identity. So we're given a cross product and addition of two vectors and with the magnitude of them squared. So I'm just going to rewrite that. So I have A cross B squared plus A, sorry, that's the dot product between the two vectors. A squared B squared. Okay, so we're asked to prove this identity. So let's say this is the left side, right side, so let's try and make the left side equal to the right side. So I'm going to evaluate the left side first. Okay, so the cross product we know is equal to the magnitudes of each of the vectors times the sine of the angle between them, right? And the dot product between two vectors is going to be still the magnitude between of the two vectors times the cos of the angle between them, right? So if we plug these in place of the cross and the dot product, let's see what we get. We end up with a b sine theta squared plus a b cos theta squared. Okay, so if I distribute the squares inwards, I can factor out the square of the magnitude of vector 1 and the square of the magnitude of the vector 2, which leaves me with sine squared theta plus cos squared theta. Right? This is a trig identity you should be familiar with. Sine square plus cos square is going to be just 1, right? So this gives me the magnitudes just squared, right? So that's what I've simplified the left side to be. So let's check the right side again. My right side is just the product of the magnitude squared, so my left side is equal to the right side, so I proved my identity. Okay, so let's move on to the next question. So this is a grade 12 data management question, so it's dealing with binomial distribution. So we're told that 84% of adult carpenter ants weigh less than 256. A random sample of 117 ants was obtained by researchers. We're asked to determine the probability that exactly 96 or 97 of the ants in the sample weigh less than 256. Okay, so we're going to say, first of all, what they've given is that the probability that an ant weighs less than 256 is 84%. Right? So question A is asking me, what's the probability that I have exactly 96 ants that are less than 256, and then 97 ants that are less than 256, right? So I have a probability of success, probability of failure. My probability of success right now is 0.84. My probability of failure is 0.16. This is all still for the number that my carpenter ants weigh less than 256, right? And the total sample size is currently 117. Okay, so if I'm looking for a probability that exactly 96 would be less than 256, I'm going to use the binomial distribution equation to say sample size over the number I'm looking at right now, which is 96, right, times the probability of success raised to the number of ants that I want to be less than 256. Right, so my probability of success is 0.84 raised to 96, and my probability of failure, which is 0.16 raised to 21. So if I evaluate this should end up being approximately 0.082. So my probability that exactly 96 would be less than 256 milligrams would be approximately 8%. Okay, so it's the exact same method to find for 97, right? So my probability distribution ends up being 117 over 97. My probability of success would be 0.84 still, but the number changes from 96 to 97, and my failure goes from 21 to 20. Okay, so this will be roughly 0.093, not a big jump. So my probability that exactly 97 ants would be less than 256 would be approximately 9%. So that's for each of the 96 and 97, but the question's asking what's the probability that 96 or 97 ants weigh less than 256. Right? We found each of the probabilities, so what we have to do is just add them up together right now. So we have 0.082 plus 0.093. Right? This is the probability of x is equal to 96, probability that x is equal to 97. If I add them up, I should get 0.175, right? So it's approximately 17.5% that the ants, probability of 96 or 97 ants weighing less than 256. Okay, so let's go ahead and move to the next question. So we're dealing with a factoring question right now. So the usual equations that we usually see are quadratics with x to the power of 2 and so on, right? How are we supposed to factor something that doesn't look like that? So what we should be doing is looking for patterns and trying to simplify this first, okay? So let's go ahead and expand this bracket first, okay? So I'm going to expand the bracket to give me 4x squared plus 12xy plus 9y squared minus 10x squared still, and I'm going to leave the last two terms the way it is. Right. And then I'm going to collect the like terms. So I'm going to simplify this to be negative 6x squared plus 12xy. So plus 12xy minus 15xy leaves me with minus 3xy. Right, and I still have plus 9y squared. Okay, so at this point what I'm going to do is factor out any common terms in my equation. So I have 3 that I can factor out, right? So I can just rearrange this to be 9y squared because I don't really like the negative. I'm going to keep the 3x in the middle and take the x squared to the end, right? And then I'm going to factor out 3 from every single term. Okay, so I end up with 3y squared minus xy minus 2x squared. Okay, so then I can basically look at what is 3 times negative 2, that's negative 6, and then try to look for common factors which add up to negative 1, right? So negative 3 and positive 2 would add up to negative 1. So I'm going to introduce 3y squared, negative 3xy, and positive 2xy into my equation, and leave the final term the way it is. Right? So then I'm going to group the first 2 terms and the last 2 terms, leaving the common factor outside still. So I end up with 3y, when I do that, y minus x, right? Because I grouped the first 2 terms and the last 2 terms, and I'm common factoring out again. So then I'm going to common factor from the last 2 terms. I'm going to take out a 2x, which leaves me with y minus x, right? And notice how y minus x is in both the terms, so I can factor that out fully. So this gives me 3y minus x, and the remaining bracket would be whatever the common factor was. So I have 3y and 2x, so I have 3y plus 2x as my second factor. Okay, So we'll do one last question. So this is asking me, what is the equation of the line with the x-intercept of -2 and a y-intercept of 6? So x-intercept of -2, meaning I have a point that is -2 and 0, and a y-intercept of 6, meaning I have a point that is 0 and 6. How do I know that? At an x-intercept, right, what axis is it going to cross? It's going to cross the x-axis, and any x-intercept will have a y value of 0 because my y value at the x-axis is always going to be 0, right? Similarly, when I'm looking at the y-intercept, it's going to pass the y-axis, and my x value is always going to be 0, right? So I have 2 points, and I already know the y-intercept, right? So I'm going to say y is equal to mx. My b value is my y-intercept, which is 6. I'm going to just plug that in. So I have a y equals mx plus 6 equation. How do I find the slope? So my slope, I need 2 points, which I found earlier. So I'm going to use those 2 points to find the slope. So my slope is y2 minus y1 over x2 minus x1. Right? This is equal to, I'll say this is 0.2, 0.1. So I have 6 minus 0, 0 minus minus 2. Right? This gives me 6 over 2, which simplifies to just 3. So my slope ends up being 3. So they told me what's an equation of a line, so I came up with the y-intercept because they gave it to me. And I found the slope by doing y2 minus y1, x2 minus x1. Plug the 2 points that I found earlier to give me an equation of 3x plus 6. Alright, so that about does it for me today. So just a quick update, the next live will be May 27th, which is next Monday. So thank you for tuning in, hope this has been helpful. Hope you guys have a good night. Take care.